for the time being. Uh, so we're looking at rational equations, and rational, the root of that is ratio or fraction, so fractional. The case of having a variable on the bottom introduces possible undefined values of x. All right, so that's one of the things that we have to check for. All right, so you could read the blurb there, but basically it's going to be, if you're looking for a process, the first thing we're going to do is check for undefined terms. Well, really undefined values of x. All right, so that's the first thing we would do in any case in which x is in the bottom of a fraction. Plus, then we're going to get it so that the equation is equal to 0. All right, so we're going to manipulate it algebraically so that everything is on one side and 0 is alone on the other. All right, so we would cross multiply. Or multiply by a common denominator. And solve for 0. All right, it's kind of a weird thing to say, solve for 0. What does that mean? Solve for x means get x alone on one side of the equation. So solve for 0 means the same thing, just 0 instead of x. All right, so get 0 alone on one side of the equation. All right, so then apply the 0 product property and solve. All right. So the tricky step in this, I mean, assuming that you're proficient with factoring, which it takes people different amounts of time to get there. All right. Some longer than others. And it took me a while. So when I was first learning it, that second step is going to be the tricky one. Because it's, okay, cross multiply or multiply by a common denominator. Well, which one do I do when? Well, you can, if it's one fraction equal to one fraction, you can use either method interchangeably. But if there's a sum or difference of two fractions on either side of the equation, then you're going to want to go with the common denominator approach. All right. So I'll show you both ways because it's not really too complicated to do it either way, and then you can go from there. Yeah, so just be on the lookout for any instance in which there's a sum or difference. I didn't put any in this assignment, but we'll get there, where you have something like I'll just kind of throw a little add on here, like plus 2 over x, something like that. So that would be an instance where you would want to use the common denominator approach rather than cross multiplication. All right. So, but before we even get there, we're checking for undefined values of x. All right. So the way we handle that is by taking our denominators and setting them equal to 0. Because what we're looking for, any instance in which the fraction would be undefined, that would happen if your denominator or denominators are equal to 0. All right. So what we're going to do is basically willfully set them equal to 0. Right, so I'm going to take the x minus 3. That's a little too light. The x minus 3, I'm going to set that equal to 0. And I'm going to take the x and set it equal to 0. All right, it's usually a pretty easy process. All right, sometimes it involves some factoring, but it's just got to be done. This is not one of those cases because the powers of our equations here are no higher than 1. All right, so I'd solve for x. X equals 3 and x equals 0. All right. So this would tell us that the equation is undefined if x is equal to 3 or 0. These are not answers. These are anti-answers. All right. These are values that could never satisfy the equation. All right. So undefined if x is either of these values. All right, so we kind of put this information aside, put it in our pocket, hang on to it for later. Because when we go ahead and solve the equation for the value or values of x, we're going to keep an eye out for a 3 or a 0. All right, because if we get a 3 or a 0 when we solve the equation, we just determined that those would make the original equation undefined. Those can't be the answers. So we would strike them out from our solution set. All right? But then whatever remains would actually be our answers. Now, you can kind of get ahead of this a little bit if you go to Desmos, but I'll cross that bridge in a minute. All right? Or a few minutes. So we have the 4 over x minus 3 is equal to 2 over x. We're going to cross multiply. All right. And cross multiplication is a simple process, but it only applies if you have one fraction equal to another fraction. All right. So you just multiply along the diagonals. If I can get diagonals to show up here, hold on. All right, so this method only works if you have single fractions on either side of an equation. If you have a sum or difference of fractions, this technique is not going to work without you doing some other algebra to clean it up. That's why I'm going to show you a second method in a minute. All right, so when I cross multiply, I get 4 times x, so 4x. I get 2 times x minus 3, so 2 parentheses x minus 3. So this is kind of annoying. I don't know how I forgot this, but this isn't a quadratic, so we don't have to apply the zero product property. We just have to solve for x, because when I distribute the 2, I get something where I can just apply properties of equality. 2x minus 6 is equal to 4x. In my infinite wisdom, I must have put this problem in here as like kind of a warm-up to the quadratic type of problems, but it's not going to require factoring. So subtract 2x, subtract 2x. You get 2x is equal to negative 6. Divide by 2, and you get x is equal to negative 3, only the one solution. And that solution is not one of the two bad values we came up with earlier. So I know that this would actually be the correct answer. All right. Now, what I was mentioning before is if you wanted to, at least in the interim until we get to the more complicated types of fractional equations, you can multiply by a common denominator. And all that means is take every denominator and multiply it by every part of the equation. All right, every unique denominator anyway. So I have two unique denominators here, x minus 3. This technique will work all the time. This is why I'm introducing it. All right, so take each denominator. We have the x minus 3 and the x. Those are two unique denominators. And multiply them by both sides of the equation. All right. When you carry out the multiplication, I'll show the intermediate step, and then I'll show you why you would never have to do that. When you multiply a fraction by another number, you're really only multiplying the numerator of that fraction by the other number. So in this case, I'd be looking at 4x times x minus 3 over x minus 3, and 2x times x minus 3 all over an x. All right. This is an unnecessary complication of the process. You wouldn't have to write this, because in this next step, what I would do is I would say, oh, look, I have two common factors on either side. I have an x minus 3 on the left. Those would divide to equal 1. I have an x on the right. Those would divide to equal 1. And I'd be left with 4x is equal to 2 times x minus 3. But I could have done that a step earlier. By looking at this, I could say, oh, I have that common x minus 3. I have a common x. I can just wipe them out right here and just multiply whatever remains. And that would get me to this step immediately. All right. Once you get to this step, it's really the same as what we did after the cross multiplication. And like I said, at this point, it's two methods that you could choose from. All right. Now you look at it and say, well, why would I ever do it this way? The other way seems so much simpler. Well, the cross multiplication is only going to work if it's a single fraction equal to another single fraction. This technique is going to work if you have multiple fractions being added together, which will happen fairly frequently. All right, so it's a good idea to have both techniques in your pocket. But in this case, the zero product property didn't apply, regretfully, but it will in the next one, so I'll show you. All right, so in number 2, again, we're going to check for undefined terms, undefined values of x, which is really the, I don't want to call it the annoying step because it's absolutely necessary, but it's the most commonly forgotten step, which from a student perspective makes it annoying because you forget it, I take off credit, and you get annoyed by that. All right? So yeah, don't forget it. Very important. You can always check your answer, but that's also something that people tend to forget to do. So it's a matter of study and practice, get in the habit of doing it. All right, so you look at your two denominators. Sometimes you could just look at it and say, oh, this number will make the bottom of the fraction equal to 0 and just kind of run away with it. But most of the time you're going to have to set it equal to 0 and solve because it'll be more complicated than this. All right, so make a little note that these are for undefined values of x. So I take my x squared minus 4, set it equal to 0, and I take my x minus 2, set it equal to 0. All right, so this is where factoring kind of worms its way into the whole situation because I'm looking at a difference of two perfect squares. X squared minus 4 is equal to 0. X squared and 4 are perfect squares and they're separated by a minus sign. So I'm going to factor that to x minus 2, x plus 2, all equal to 0. Well, the product's equal to 0 anyway. All right. I'm solving a quadratic, even though I'm solving it for an anti-answer, an anti-solution, an undefined value of x. It's still solving an equation, so I'd still apply the zero product property. All right, that's telling me that x minus 2 is equal to 0, or x plus 2 is equal to 0. And then you could solve those and get x is equal to 2 or x is equal to negative 2. All right, which actually makes the second equation irrelevant because x minus 2 equals 0 is already accounted for. All right, we've already done the work there, so it's not necessary to do it again. All right, so these would be the undefined values of x. So we do this before we even get started with the solution to the problem. All right, so these are my unanswers. All right, now I'm looking for my answers. So to do that, I'm going to take my original equation in its original form, and then, pick your favorite method. Right? Either cross multiplying or multiplying both sides by the common denominator. They both amount to the same thing. All right? Just it's a little easier when it's a fraction equal to a fraction to do it with cross multiplication. All right, so I'm looking at x minus 2 times x minus 4 is equal to negative 2 times x squared minus 4 for equality 2. Even the most complicated algebra isn't difficult conceptually. It just takes longer to do because you have to do it. It's kind of like doing a push-up. Assuming you can do a push-up. I mean, I can barely do one these days. But like in my prime, you do a push-up and you're like, okay, I can do this. Now do 1,000 of them. I know I can do it. I just don't want to. It's oftentimes that way with the algebra. So that's my preamble to what we're about to do. We have to get everything over to the same side of the equation here, which is going to involve this being in the general form for a quadratic, which means everything has to be distributed out. So we have to double distribute on the left. So we get x squared minus 4x minus 2x plus 8. And then we have to distribute that negative 2 on the right. Combine like terms. Solve for 0. All right, so these two can be combined. So I'm looking at x squared minus 6x plus 8. Everything still has to get to the same side, so it's a question of if I'm going to bring 3 terms to the right or 2 terms to the left. It seems like it would be a little bit less work to bring 2 terms to the left. So I'm going to add 2x squared to both sides. Something nice happens when I subtract the 8. It cancels from both sides. So I'm looking at 3x squared minus 6x is equal to 0. So then I look at this and I say, okay, well, 2 terms. There's a minus sign, so maybe it's difference of 2 perfect squares, but the 3 is not a perfect square, nor is the 6. So I'm thinking GCF, which is really the first thing I should be thinking of anyway, but we get there eventually. All right, 3 goes into both 3 and 6. There's an x in each term, so I'm going to divide each of these 2 terms by 3x. But we don't lose it, we keep it. All right, so that's going to give me an x minus 2. 0 product property. I'm going to take my 3x, set it equal to 0. And I'm going to take my x minus 2, set it equal to 0. I'm going to solve each of these 2 equations. One of them, well, they're both pretty easy, but one of them involves division and the other involves addition. So we get x is equal to 0 or x is equal to 2. And if you didn't handle the undefined terms initially, you might not realize that 2 could never have been an answer. It's not a solution to this problem. All right? The algebra makes it seem like it is, but it's not. All right? We determined that 2 is one of the undefined values up here. So I would then eliminate x equals 2 from my final answer. and establish that it's just x equals 0. Examples. The first one, it really isn't such a great example because it doesn't involve quadratics. And I did number 2 with the other class, so I'm going to hop you over to the next page and do a couple of problems there. All right, so we'll start off with number 3, and then we'll do a more challenging problem. All right, so the first step in the process is to check for undefined values of x. All right, and so okay, what does that mean? So undefined values occur when the denominator of a fraction is equal to 0. All right, so undefined values of x. That's what we're looking for. We look across our denominators. Any denominator that contains an x can potentially be undefined. So we take any of those denominators. In this case, there's only one denominator that involves an x, and we set it equal to 0. And solve. All right. In some cases, it's not that difficult to do. This is one of those cases, because all I'd have to do is subtract 4 from both sides, and you get x is equal to -4. All right. Now that's not the answer to the question. If it is, then, or if it was, then this would be a whole lot easier than I'm making it seem. All right. This is actually the opposite of an answer. This is an anti-answer, unanswer. All right. We're going to solve this equation in a second, and if we come up with x equals -4, that's not the answer. All right, we would eliminate that as a possible solution because x equals -4 would make this fraction undefined. All right, so it's a bad number. All right, so when we go through the process of solving, we can use one of two methods. One method is just simple cross multiplication. Now, cross multiplication only works when you have two fractions set equal to one another. All right, a single fraction on the left side of an equation, single fraction on the right side of an equation, as in a proportion, and nothing else. All right. So I'll show you the other method because that's not always going to be the case. You know, we're not always going to just have a single fraction on either side of the equation. All right. But when you do, it's not that bad because it really is just a matter of multiplying across the diagonals. So I'm going to take the x, multiply it by x plus 4. I'm going to take the 6 and multiply it by the x. All right. I also can go the other method or use the other method, and that would be to multiply by a common denominator. Now, a common denominator is just each unique denominator in your fractional equation. All right? Rational equation, ratio, fractional equation, they're all really talking about the same thing. All right? So I'm going to take each denominator across my rational or fractional equation and multiply it by each part of that equation. All right? So I have two denominators here, two unique denominators, a 6 and an x plus 4. All right? So I'd multiply both sides by 6 and an x plus 4. A 6 and an x plus 4. All right? On the left-hand side, the 6's are going to cancel out because 6 divided by 6 is equal to 0. I almost said 0. I almost said it. 6 divided by 6 is equal to 1. X plus 4 divided by x plus 4 is also equal to 1, so they cancel away. So on the left-hand side, you have an x plus 4 multiplied by an x. That's the same as saying x times x plus 4. On the right, you have a 6 times x, which is the same as saying 6x. All right? It seems like a more roundabout way of doing what we did over here. But this method works in more situations, the one on the right. Right? So it really doesn't matter for these kind of problems which method you use, but down the line, you're gonna end up finding that you're gonna be using this method more frequently, and that you won't be able to use this method, or you'll have to do a lot of background algebra in order to make it so that you can use this method, and you'll say, oh, okay, well, it'll just be much easier to use this technique. All right, I guess I don't need a bar that's that big. So now we want to go through the process of solving the equation. I only have to do it for one of them because they're the same. So I want to apply the zero product property, but in order to do that, I need a factored form. In order to get a factored form, I need to have the general form of the quadratic, all right, which means I have to distribute this out. X squared plus 4x is equal to 6x. The zero product property is an expression, or only applies when you have an expression equal to 0. So I need to solve for 0. All right, solve for 0, what does that mean? Same thing as solve for x. What do you do when you solve for x? You get x all by itself. Solve for 0, get 0 all by itself. So I'm going to subtract the 6x from both sides. And that's going to give me x squared minus 2x. Doesn't matter what's on the left, as long as on the right you only have a 0. All right, so mission accomplished. Now I can apply the zero product property. And I would do that using whatever factoring technique makes sense. All right, that's the last challenge in the problem. All right, because sometimes you look at a question and you say, oh, well, I don't know what factoring technique makes sense. All right, but you count the number of terms. There's only 2 terms, so it's not a trinomial method. So it's either a GCF or a difference of 2 perfect squares. All right, so I don't see 2 perfect squares. I see a difference, but that 2 is not a perfect square. So I'm leaning more towards the GCF approach. So GCF here, well, I don't have a common numerical value, but I can pull out an x. I have a common x that can be factored out. All right, so divide each of these terms by x. And you get x times x minus 2. Apply the zero product property. Set each of those factors equal to 0. X equals 0 or x minus 2 equals 0. Solve for x. And you get x is equal to 0 or x is equal to 2. Then, so that could be your final answer, but we do need to check it against our undefined values of x. So then we go take a look at our undefined values of x and see if any of the numbers we just came up with are in the set of undefined values. All right? So the undefined value, in this case value singular, is -4. That's not one of the values we just came up with. If it was, we would eliminate that value from our solution. All right, so these 2 would make up our solution set. All right, but if one of those was a -4, I would dismiss it. All right, so that's complicated enough, but unfortunately, it's not the most complicated type of problem. So let's do something a little bit juicier. Do number 6. All right, so again, we check for undefined values of x. It's always going to be your first move. Anytime you have a fractional equation, I'll just try to keep that up on the screen a little bit longer. All right. For undefined values of x, is any instance in which the equation could be undefined. So I have to look at any denominator that has an x in it. I get an x minus 2 and an x minus 4. So each of those are going to get set equal to 0. then solve. X equals 2, x equals 4. All right, technically ORs, because it could be either of those that make the fractional equation undefined. So now we have to solve the equation. All right, so we have x plus 2 over x minus 2 is equal to 4 over x minus 4. And again, you could do it one of two ways. You don't have to do it both ways. You just got to be prepared for when eventually you'll need to use the second approach. All right, but for now, you could just use the first approach if you want. All right, and that first approach is just straight cross multiplication. So x plus 2 times x minus 4 is equal to 4 times x minus 2. All right. For the other approach, we just multiply by each unique denominator. We got these two guys. Multiply both sides. We have an x minus 2, x plus x minus 4. All right, we have the common x minus 2 that cancels away over here, divides to 1. We have the common x minus 4 that cancels to 1 also, leaving us with an x plus 2 and an x minus 4 on the left side, and leaving us with a 4 and an x minus 2 on the right side. So it, like I said before, or maybe I didn't, I don't know, possibly in the other class. It just seems like a more complicated way of doing the same thing, but only for these kind of questions. It'll be absolutely necessary down the line. All right. So anyway, I want to solve this equation. Regardless of how we get here, we're here. So I need to distribute this out. So x squared minus 4x plus 2x minus 8. Distribute this out. 4x minus 8. All right, combine any like terms on the left side. I definitely have at least these two like terms. So x squared minus 2x minus 8 is equal to 4x minus 8. I want to be able to apply the zero product property, which means I have to have a zero product. 0 has to be alone on one side of the equation. Right? So I have to solve for 0. So to do that, I'm going to subtract the 4x and add the 8. Both cancel on the right-hand side, and fortunately, the 8 and the negative 8 will cancel on the left-hand side. So I'll have x squared minus 6x is equal to 0, another GCF situation. Not always going to be GCF situations, but when it is, it's nice. It's a little easier to do. All right, so pull out my GCF. In this case, an x. Divide by x. And we get x times x minus 6 is equal to 0. Set each of those factors equal to 0 and solve. All right, and so we're looking at x equals 0 or x minus 6 equals 0. It's a different shade of green, I think. Which gives us x equals 0 or x equals 6. Neither of which are one of the undefined values. So we don't have to worry about eliminating either of them. The same situation as before. All right. So again, if one of these values were either a 2 or a 4, we would dismiss it as not being an answer, or not being a correct answer. But there it is. That's our solution. All right, now as far as Desmos is concerned, you can come up with the answer without doing any of this work. But again, I mean, if you need to show all work, then having the answer is only going to get you so far. But it's a good way of checking your work. You know, so if, for example, like number 5, if I wanted to do that one on Desmos, all you'd have to do is type in the left side as one equation and the right side as another equation. All right, so you type in y equals 8 over x squared minus 64. All right, pretty funky looking graph right there. And y equals 1 over x minus 8. Also a pretty funky looking graph right there. And we would be looking for intersections between these two graphs. Now, sometimes it's hard to see. All right, but if you start tapping around, if there's an intersection, a gray dot will appear. One of them appears right here. So there's a gray dot. That's telling me when x is equal to 0, we have a solution. All right, and you could check it by plugging it into the original equation and see if left side equals right side. But that looks like one answer. Then you start hunting around, you know, just tapping away, see if there's any other instance in which these two graphs are equivalent to one another. It does not appear that that's the case. Now, as you go further and further out to the left and to the right, it looks like they kind of merge with one another, but they never actually do, because let's say I get out over here to like 150, negative 150. It looks like they're two curves that have merged together. But if I zoom in, I see that they're still separated. All right, and that's because they're what we call asymptotes. All right, those are curves that approach a line but never actually touch. Right? And so it'll go out to infinity and never actually touch, even though it'll seem like it does. Right? So any instance where a graph appears to merge, those aren't going to be solutions. The only other instance, so up here we would disregard, over here we would disregard, down here same deal. The only other instance where they actually intersect would be here when the x value is equal to 0. So I'm pretty confident that that would be my solution. All right? But you could work it algebraically also. I mean, I'm kind of in for a penny now, so might as well. All right, so we check for the undefined. All right, and so that's the case where we just set the denominators equal to 0 and solve. So x squared minus 64 is equal to 0, or x minus 8 is equal to 0. All right. Now this one, I guess, when it comes to the undefined, it's a little trickier because you have a quadratic in your undefined computations. And so we got to deal with that real quick. But it's not a difficult quadratic. It's just difference of perfect squares. X squared minus 64 is not terrible. All right, so that's x minus 8, x plus 8. All right, so zero product property tells me that x minus 8 is equal to 0, or x plus 8 is equal to 0. Solve each of those, you get bad numbers of x equals 8 or x equals negative 8. Remember, undefined are the anti-answers. All right, which makes our second equation irrelevant because x minus 8 equals 0 is already part of this computation, so I don't need to do that again. All right, so then I just want to cross multiply. Computationally, this one isn't terrible. All right, 8 times x minus 8. And then 1 times, well, anytime you multiply something by 1, that's not a bad deal. 1 times x squared minus 64, that's pretty nice. We don't need to double distribute here, which is also nice. 8x minus 64 is equal to x squared minus 64. I think it makes more sense to bring everything over to the right. So I'll subtract the 8x and add a 64. So I'm looking at 0 is equal to x squared minus 8x, because the negative 64, positive 64 are going to cancel away. I see a GCF of x again. A lot of GCF problems. So pull out that GCF. Set each of those factors equal to 0. And solve. But in this case, if we refer back to our work for the undefined terms, we see that we have an x equals 8. That's an unanswer. That's an anti-answer. That's a bad answer. That can't possibly be correct. All right? So x equals 8 gets dismissed because it's a value that would make our original equation undefined. So the only valid answer here would be x equals 0, which is what we came up with in Desmos. X over 6 is equal to x over x plus 1. So the first thing we do is we check for undefined values. All right, the way we do that is by taking each unique denominator that involves a variable and setting it equal to 0. All right, so this one doesn't have a variable in the denominator, so I'm going to disregard that. But this one does, so I'm going to set this equal to 0 and solve for x. All right, should be pretty straightforward in most cases. Sometimes you have quadratic in the bottom of a fraction, in which case you have to factor. That happens from time to time. So we'll cross that bridge in a minute. But for now, it's pretty straightforward. X equals negative 1. Right? So this is not an answer. This is what I was saying before. This is the opposite of an answer. These are values to be avoided. All right? Or in this case, the value to be avoided. So now that we know that, we can go down one of two pathways in order to solve this equation. So we have 2x over 6 is equal to x over x plus 1. We can either cross multiply, or we can multiply both sides by the common denominator. Right? There's pros and cons either way. Cross multiplication only works if you have a single fraction equal to another single fraction. Right? It's known as a proportion. Right? So if there's addition or subtraction involved on either side of the equation, then this technique wouldn't work. So, for example, if this question, and we'll get to problems like this, which is why I'm showing you both ways. If we had something like 2x over 6 equals x over x plus 1 plus 1 over x, something like that, where there's a sum on one or both sides of the equation, then you would not be able to use this method. All right? But as it turns out, that's irrelevant here, so we'll just cross multiply. All right? The alternative to that approach would be to multiply both sides by a common denominator. Multiplying both sides by a common denominator is basically the same as multiplying both sides of the equation by each unique denominator. All right? So here I have a 6 and an x plus 1. So I would multiply both sides by a 6 and an x plus 1. And of course, I never leave myself enough room. All right, if any of the values were repeated, like if there was another fraction that had a denominator of 6 in it, I would ignore it. All right. When you do this, something should cancel. It'll take your fractional equation and make it not fractional anymore. Right? So on the left side, I'd have a 6 divided by a 6, which would be a 1. 6 divided by 6 cancels to a 1. And I would be left with 2x times x plus 1. I could write it in either order, so I like to keep the monomial in the front. All right. On the right-hand side, the x plus 1s would cancel, and I'd be left with an x times 6, or 6x. And that would be the end of it. Right? At least in terms of that part of the simplifying. We still have to solve the equation, but it's not a fractional equation anymore, so it's much more manageable. Now, alternatively, we could have cross-multiplied, in which case we would take the 2x and directly multiply it by the x plus 1. And we would take the x and multiply it by the 6, or the 6 multiplied by x, and get 6x. So you get there in one shot, but like I said, pros and cons either way. This way only works when it's a single fraction equal to another single fraction. And if there's sums and differences on either side, it'll all fall apart. All right, but ultimately you get to the same place. So continue. We want to solve the quadratic. The way we would have to do that by using the zero product property is to get a zero product, as in everything alone. Everything on one side is 0 alone on the other side. So in order to do that, I need to distribute the 2x. 2x times x is 2x squared. 2x times 1 is 2x. And we have a 6x here. All right, if I'm going to solve this equation by getting everything on one side and 0 alone on the other, I'm going to subtract the 6x from both sides. And that's going to give me 2x squared minus 4x equals 0. So then I need to think about how I would solve this equation. All right? So the possibilities are, it's a trinomial, there's a GCF, could be a difference of perfect squares, anything's fair game. All right, so count the terms. There's 2 terms, so it's not a trinomial. All right. Difference of 2 perfect squares. Well, the 4 is a perfect square, the x squared is a perfect square, but the 2 and the x aren't, so that's out. So it must be GCF. The GCF is x. There's a common x. Well, there's also a 2. Each of these numbers is divisible by 2, so I can factor out a 2 and an x. So divide each term by 2, x. That's going to give us 2x times x minus 2. Apply the zero product property, which is to say set each factor equal to 0 and solve. So 2x equals 0, or x minus 2 equals 0. If I divide both sides of the first equation by 2, I get x equals 0. If I add 2 to both sides of the equation, the second equation, I get x equals 2. So then I take a quick look at my undefined values and make sure that these values don't coincide with any of those over undefined values. All right, so if I did all this work and I got x equals negative 1, well, x equals negative 1 would make the fraction undefined, well, the fraction on the right side of the equation. And so I would dismiss that as an answer. I would exclude it. I would cross it out. Okay? So, there's a lot going on here, but, it's very procedural. First, you find your undefined values. Then you either cross-multiply or multiply both sides by a common denominator. Then you get everything over to the same side of the equation and solve for the value of x, which is, I think, the trickiest part, because that's the part that requires you to factor. All right, if you struggle with factoring, you could run into a little bit of trouble there. All right, we'll do another one. I might steal one from your homework. Yeah, I'll steal one from the homework. Just trying to decide which one. Number 8's a little funky. All right, so again, we're looking for excluded values, as in values that make the fraction or fractions undefined. So undefined values. Take each unique denominator that involves a variable and set it equal to 0. There's two instances here. All right, now this is tricky because that first equation, it's not a difference of two perfect squares, and it's not a GCF situation. It's definitely not a trinomial. So this isn't something that we could factor using rational numbers. Yeah, there is a way to do it that involves irrational numbers, but we're not there, all right? So the only real value that we would get here would be x equals 0. Now I can show you, when you have a quadratic in binomial form, you can solve it without factoring, but oftentimes people lose a solution. All right, so it's not really the encouraged way of doing it. But if you wanted to, you could add 8 to both sides. You get x squared is equal to 8. We want x, not x squared. You think, how can I get an x squared into an x? You take the square root. All right, the square root of x squared is x. The square root of 8, it's irrational. Pop it into a calculator, and you get a funky decimal. Right? The issue that people run into here is that when you take the square root of a number, it's not just a positive value, it's negative also. So plus or minus radical 8. And there's ways of simplifying that, but we'll get to that in the second half of the unit. But for now, we could just leave it like that. So the possible undefined values, or the undefined values, would be negative radical 8, positive radical 8, or 0. Right? Any of those would make these two fractions, well, one or both of the fractions undefined. Right? So then, now that we have that information, we can go through the process of solving the equation. We have x over x squared minus 8 is equal to 2 over x. And if you use cross multiplication, x times the x gives you x squared. And then we're taking the 2 and multiplying it by x squared minus 8. So 2 multiplied by x squared minus 8. A little distributive property. So 2x squared minus 16. If I'm going to apply the zero product property, I need everything over on the same side of the equation. All right, so I would subtract off an x squared from both sides. That's going to give me a 0 on the left and x squared minus 16 on the right. Which is factorable. That is a difference of two perfect squares. All right, the x squared minus 8 was close. That 8 screwed everything up. But here I have two perfect squares. X is raised to an even power, and 16 is perfect, and there's a minus sign. So I could factor this to x minus 4, x plus 4. Set each of those factors equal to 0. And solve, and you get x equals a positive 4 or x equals a negative 4. And again, you just take a quick glance at your undefined values and see if any of those coincide with your answer. Turns out they don't. And honestly, I got to tell you, it's not going to happen very often where you'll have a overlap between your undefined values and your answers, your real answers and your unanswers or your anti-answers. But when it does, it's important, right? So it it happens so infrequently that people will question the need to determine undefined values to begin with. Right? But you got to do it. Right? So you got to show that step. Right? And again, if you wanted to do it the other way, there really is, it's only a couple of steps that are different. You'd have the x over x squared minus 8, again, equal to 2 over x. You multiply both sides by each unique denominator. I have two unique denominators. I have an x squared minus 8, and I have an x. I would multiply both sides by both of those. I mean, you're going to need to know how to do it this way at some point anyway. So, no time like the present, I guess. All right. Cancel any common factors. The x squares would cancel here. I'm sorry, the x squares minus 8s. And the x's would cancel over here. And you would be left with x times x, which is x squared, and 2 times the x squared minus 8. And that's going to get you to this step, and everything else is going to be the same. So it's really just a slight difference, but this approach is more flexible in that it'll handle many more situations than just the simple cross multiplication. All right.